You send your perfect 3D design to a machine shop, and they ask, do you want this run on a 3-axis or a 5-axis machine? They're both CNC, so what's the actual difference? Today, no dry engineering jargon. We're looking at this strictly from a designer's perspective to see how this choice impacts your product, your timeline, and your wallet. The core difference comes down to one word: freedom. With standard 3-axis machining, the cutting tool can only move along 3 linear paths, X, Y, and Z. Think of it like holding a pen perfectly vertical. Your hand can move up, down, left, and right, but the pen tip always points straight down. If you need to machine the bottom of the part, the machine has to stop. An operator has to manually flip the part over, reclamp it, and start again. 5-axis machining, however, gives the machine a wrist. It adds to rotational axes. Now, the tool can tilt and carve from almost any angle. The part stays put, and the machine gracefully dances around it to get the job done in one single setup. As a designer, this choice directly impacts your final product in 3 massive ways. First, design freedom. 3-axis forces you to compromise. If your design has undercuts or deep, complex cavities, a 3-axis tool simply can't reach them. You'd have to split your product into multiple smaller pieces and bolt them together later. 5-axis allows you to manufacture wild, organic geometries as a single, solid piece. Second, surface finish and accuracy. When an operator has to manually flip a part on a 3-axis machine, it introduces tiny human errors. We're talking microns, but it adds up. It can leave slight misalignments and visible tool marks. 5-axis machines do it all in one go, maintaining a flawless, mirror-like finish and perfect geometric alignment across all faces. And third, the lead time paradox. 5-axis isn't always faster, it depends on your volume. If you are doing a single prototype, 5-axis is actually slower. The upfront time required for complex programming, anti-crash simulations, and ultra-precise tool calibration takes ages. A 3-axis machinist could flip the part by hand and finish it before the 5-axis even starts cutting. But for mass production, 5-axis wins by a landslide. Once the program is set, it eliminates hours of manual flipping and refixturing across thousands of parts, slashing weeks off your final delivery time. So, if 5-axis gives you more design freedom and dominates in mass production, why not use it for everything? Because doing that might ruin your budget. First, it's a massive hit to your wallet. 5-axis machines cost a fortune and require highly skilled, highly paid CAM programmers. If you are designing a relatively flat enclosure, a mounting bracket, or simple panels, a 3-axis machine will give you the exact same result for a fraction of the cost. Using 5-axis here is just paying a massive premium for technology you don't need. Second, size constraints, because 5-axis machines need extra room for the table to tilt and rotate without crashing. Their maximum part size is usually much smaller than a 3-axis machine of the same physical footprint. Big, heavy structural plates are actually much better suited for the raw, rigid power of a 3-axis machine. So, let's make it simple. Here is your ultimate decision framework. Stick with 3-axis if your part is geometric, mostly flat, features are concentrated on 1 or 2 sides, or if you're just making 1 or 2 early stage prototypes, it saves you both time and money. Upgrade to 5-axis if you are designing complex, organic surfaces like an ergonomic mouse enclosure, or if you are moving into high-volume mass production where consistency and zero human error are paramount. Choose the right tool for the job and protect your design and your budget. If you found this helpful, hit that like button, subscribe, and I'll see you in the next one.